Right, guys. So for this lesson, we technically have kind of already started talking about this very informally, and we're just going to formalize word problems and the way they're written today. So the two things that we are going to focus on today are the placement of angles, because you're going to see angles of elevation and angles of depression. So they are exactly what they sound like. When you think elevation, hopefully you think up. So it is always, the angle of elevation is always measured from the horizontal line up. Okay, it's usually inside the triangle. So if you look here, this is your horizontal line from C to A. So you start measuring that angle up, and so this right here would be our angle of elevation. Now over here, when you think depression, you think down. Well, an angle of depression is always measured from the horizontal line down. It's usually outside the triangle. If you flip your triangle over, which we will talk about in a few instances, then that's not true. But I would say 9 times out of 10, if not more, it's usually outside the triangle. So what this means is this is kind of going back to Math 1 with your parallel lines cut by a transversal. So you guys see the yellow triangle here. If you have an angle of depression, the bottom line is the horizontal. Well, you can draw a parallel horizontal line up here, and then it says it's measured from the horizontal line down. So you start at the matching horizontal line and draw down to the line of sight, or whatever the case may be. And this 35 would be your angle of depression. And then you guys, because these are parallel lines, they're both horizontal lines, and this acts as a transversal right here, that should match your angle of elevation inside the triangle. Okay, so that's not a coincidence. So we're going to start just by drawing pictures, and then we'll solve a couple problems. You guys, the biggest thing is reading, paying attention to reading. Okay, this says you're standing on the beach and spot a goose on top of a building. So the goose is on top of the building at an angle of elevation of 50 degrees. The building's 140 feet high. Now we're not solving for anything. We're just drawing the picture. So you're standing on the beach and spot a goose on top of the building. So you're down here on the ground. The goose, which we all know I can't draw, is right here on top of a building. Okay, and you're looking to the goose, okay, at an angle of elevation. So angle of elevation is from your line of sight, which is the horizontal up, of 50 degrees, and the building is 140 feet high. Okay, so just getting used to the placement of things. The next one says you are standing on top of a building 100 feet above the ground. So you are standing on top 100 feet above the ground, and you spot your grandma on the sidewalk at an angle of depression of 64 degrees. So that means that you're up here on top of a building now, and you're looking down to grandma who's on the sidewalk. So you're looking down to grandma at an angle of depression. So you guys, you don't formally think this, but when you look out and then down, or out and then up. So your angle of depression, you look out and then down to grandma. You're looking down at an angle of 64 degrees, and the building is 100 feet above the ground. Okay, so we're going to draw some pictures and actually solve them now. Okay, so just really pay attention to what would make logical sense. We talked about this before. Ladders are never laying horizontally or straight up vertically, things like that. Okay, so this says a man is standing 80 feet from the base of a TV tower. So he is 80 feet from the bottom of the TV tower. Base means bottom. From this point, the angle of elevation to the top of the tower is 32 degrees. How tall is the TV tower? So the man is standing down here. Okay, he's looking up to it, and you have a TV tower over here. Okay, so this is your tower. And it says he's standing 80 feet from the base. Well, the base is the bottom, so he's 80 feet from it. And then it says from this point, the angle of elevation to the top of the tower is 32 degrees. So from the horizontal up to the top of the tower. So the line of sight from the base to the top is 32 degrees. The question is asking how tall is the tower. So we want to know that distance. That's going to be our x. Okay. So if this is x, then let's think about what we know. We know this is obviously our theta. This is opposite, and this is adjacent. So I'm stuck using tangent because I don't have a hypotenuse. So tangent of 32 degrees equals opposite over adjacent. You can throw that over 1 and cross multiply. You're going to do tangent of 32. Make sure that you are in degree mode on your calculator. Times 80. And x is approximately 49.99. So he is approximately 49.99 feet. Or I'm sorry, that tower is approximately 49.99 feet. Okay, watch your rounding there. Number 2, the captain of a boat knows that a lighthouse on the coast is 100 feet tall. Okay, so the lighthouse on the coast is 100 feet tall. Okay, if she measures the angle made from the boat, so you have a boat, to the lighthouse to be 2 degrees. So the angle made from the boat to the lighthouse. So here to here, this triangle is obviously off, is 2 degrees from the horizontal up. That should be a 2. That looks like a Z. How far is the boat from the coast? Well, remember, the lighthouse is on the coast. That's 100 feet tall. She measures the angle made from the boat to the lighthouse to be 2 degrees. How far is the boat from the coast? That's what we're looking for right here. Now let's think about this, because this doesn't actually say that it's an angle of elevation, but think logically about where things can go. We know that this is 100 feet tall. It has to stand upright. Remember, we've talked about this before. This is our 90-degree angle. Otherwise, that thing isn't standing upright. Maybe. Let's try and not make a mess of our picture. That's already not very clean. Okay. We know that this right here is going to be a 90-degree angle for it to stand upright. If she measures the angle made from the boat to the lighthouse, that it would not make any sense for the angle to be up top, because then you would be measuring from the top of the lighthouse to the boat. So this is the only logical place to put your 2 degrees. Okay, so we have opposite and we have adjacent. So again, we're using tangent. So tangent of 2 degrees equals 100 over x. Be careful here, you guys, because your variable's in the denominator. So you end up with 100 equals tangent of 2 degrees times x. So you're going to divide, sorry you guys, my computer is not loving my handwriting, both sides by tangent of 2 degrees. Okay, so in your calculator you do 100 divided by tangent of 2, and you should get it to be approximately 2,863.63, and this is feet. That's how far she is from the coast. Okay. All right, on the back. Maybe. There we go. We have a forest ranger who's looking out from a ranger station, who can see a forest fire at an angle of 35 degree. I'm sorry, I'm reading this completely wrong. A forest ranger looking out from a ranger station can see a forest fire at a 35-degree angle below him. So you guys, that tells you he is looking out and he can see the forest fire at an angle of 35 degrees below him. That means he's got to be up in the air looking down. The ranger's position is 100 feet above the ground. So we know right off the bat that if he's up in this ranger station right here, right, he's 100 feet above the ground, and he is looking out and down to the fire, right? There's a forest fire going on here. Okay. At an angle of 35 degrees. So that is an angle of depression because he is looking out and looking below him. How far is it from the ranger to the fire? Okay, so we have our triangle here. This obviously is upright. Now let's think about the angles first. We talked about this in the beginning. If this is 35 degrees, you know two things. We know that if we draw a straight horizontal line, this needs to be a 90-degree angle, okay, because this is horizontal because it's also a 90-degree angle. So this is going to be 55 degrees, okay. You also can use alternate interior angles and say that means this is 35 degrees, okay. We want to know the distance from the ranger to the fire. So how far is the ranger to the fire? We're going to do the diagonal distance here. I believe in every other question it's very clear. Technically, this one's a little ambiguous on if you find the horizontal side or the diagonal side. I always read it as the diagonal side, but you'll see as we get through the next couple of questions, and that's how they'll be on the quiz. It's pretty obvious when it's a diagonal side. But this one, technically, I couldn't penalize you for going one way or the other, but I'm going to go with the distance from the ranger to the fire like that. So, with that being said, technically it doesn't matter which angle you use. You can use the 55. If you use the 55 degrees, then you have the 100 is adjacent and the 5 is hypotenuse. I'm sorry, the x is hypotenuse, so you're going to do cosine if you use 55, and you will do sine if you use 35 because then the 100 is opposite. So it totally depends. I'm going to go ahead and use the 35. So this is opposite, and this is the hypotenuse because I'm using this angle. So I have sine of 35 degrees equals opposite over hypotenuse. Again, like the last one, you have to throw that over 1. And when you cross multiply, you have 100 equals sine of 35 times x. So you divide both sides by sine of 35. And then when you put that in your calculator, you have 100 divided by sine of 35. And you find the distance to be about 174.34 feet. Okay. Number 4, a person standing 30 feet from a flagpole can see the top of the pole at an angle of elevation of 35 degrees. The person's eye level is 5 feet from the ground. So this is throwing a little bit of a wrench in it. Normally, if it's not stated like, oh, the eye level is X amount of feet off the ground, then it's just assumed that everything is measured from the eye level. The horizontal, you don't need to worry about adding. But here, this sentence right here goes out of the way to state that the person's eye level is 5 feet from the ground, so we need to take that into account. And it says find the height of the flagpole. So you have a person and you have a flagpole. Okay. It says in the question, they're 30 feet from the flagpole. So that means this is our 30, and we know that the flagpole stands upright. And they can see the top of the pole at an angle of elevation of 35 degrees. So remember, this is like the ARIA question from last week. You look from your eyes, not from your toes. So up to here, once you look out and up, this is 35 degrees. It is saying that the person's eye level is 5 feet off the ground. So I know this distance right here is 5. We want to know the height of the flagpole. Well, you guys, that's the entire distance, and all I know right now is that this part is 5 because that part is 5. So we need to go ahead and solve for x, which is going to be this distance, and then we can add 5 to it. So if you think about it, I'm going to kind of accentuate the, that's not what I want, sorry. I'm going to accentuate the triangle that we are focusing on first. We're going to focus on this triangle here, right here, right here, and right here. Well, let's think about this. If this is a 90-degree angle down here, this is a 90-degree angle right there. If this is a distance of 30, your feet and your head, unless it's stated otherwise, are going to be the same distance, so that's 30. So now we have enough information to solve for x, and then to find the official height of the flagpole, we can just add 5 to our answer. So this is opposite, this is adjacent. So again, we're using tangent, which happens a lot with word problems just because the diagonal distance isn't usually the distance you're given. So the tangent of 35, sorry about my handwriting today, you guys, equals opposite over adjacent. So when we cross multiply, we'll just have one multiplication to do. So tangent of 35 degrees times 30 tells me that x is approximately 21.01 feet. But then remember, we need to add 5 to it because we're looking for the entire distance. So the actual height of the flagpole is about 26, if it lets me write this, 0.01 feet. Sorry, you guys. My computer does not pick up my stylus today. All right. A couple more. Number 5. We have a blimp that's flying 500 feet above the ground. A person on the ground sees the blimp by looking up at a 25-degree angle. Find the diagonal distance from the blimp to the person. So this is what I was talking about at the top of the page. Do you see how this says find the diagonal distance? It's very obvious that I want the hypotenuse there. So you have a blimp with somebody in it flying 500 feet above the ground. A person on the ground sees the blimp by looking up at a 25-degree angle. So you have a person on the ground looking up at a 25-degree angle. And I know I said you don't look from your feet, but it's not specifying, so it's assuming that all distances are. You don't need to add like we did in the last problem. Okay. This is going to be our right angle because it's the ground and it's a distance. It says find the diagonal distance. So that is your x. We're looking for the diagonal distance from the blimp to the person. So we have opposite and we have hypotenuse. Again, you guys, technically you could find this third angle and use cosine, but you're doing work you don't need to do. So we are going to do sine of 25 degrees. Oh my goodness, you guys, that doesn't even look like anything remotely legible. I apologize. All right, let's try this again. Sine, oh, and it thinks I'm also a highlighter. How about that? Of 25 degrees equals 500 over x. All right, so this is one of those where you're going to have to throw it over 1 and cross multiply. So we end up with 500 equals sine of 25. And again, you guys, you need to show as much work as you deem necessary. I get to the point where I don't need to show this step, but if you never get to that point, that's okay. Doing the math correctly is obviously the end goal. So you're going to divide both sides by sine of 25. So 500 divided by sine of 25 degrees means that you are looking at a diagonal distance of approximately 1,183 feet, 0.10. So 1,183.1. You don't need to put the 0 in. Feet. You might want to put the unit in if you want full credit there. There we go. That looks terrible. I'm so sorry, but you get it. Okay. I don't want to waste your time fixing it. All right, so we have 2 more. You guys, at this point, it might be a good idea to pause the video and try these 2 and then see how you do. See if you're grasping what I'm teaching. See if you can pick up what I'm putting down. Cool. And then come back and see if you did them right. An airplane pilot can see the top of a traffic control tower at an angle of 20 degrees below him. The airplane is 5,000 feet diagonally from the tower. How far above the tower is the airplane? So he clearly is looking down at an angle of 20 degrees. The airplane is 5,000 feet diagonally from the tower. How far above the tower is the airplane? So you have your airplane right here. Okay. And the pilot is looking out and then down to the top of the air traffic control at an angle of 20 degrees. And it says that he's 5,000 feet diagonally from the tower. How far above the tower is the airplane? So we want to know how far above the tower is the airplane. I'm just going to go ahead and do that. Could I make a triangle the other way? Completely, totally, draw your 20 in. But if I want to know the distance above, it doesn't matter if I put it here or if I put it over here. It's going to be the same distance no matter what. And now I am looking for this is my x. So this is opposite. This is hypotenuse. So I can use sine. So I have sine of 20 degrees equals opposite over hypotenuse. Time. So you have 5,000 times sine of 20. And you get approximately 1,710.10. Again, you don't need the 0, but I just do it so I know I checked it. Okay. All right, last but not least, it says a tree is leaning, and in order to keep it from falling over, a rope is tied from a stake in the ground to the tree at an angle of 23 degrees. The stake is 6 inches off the ground and the rope reaches 18 feet up the tree. How long is the rope? Okay, so you have a tree and it is leaning. So let's see if I can draw a leaning tree. I'm really good at straight up trees, but we have a leaning tree. There we go. It's kind of leaning. And to keep it from falling over, a rope is tied from a stake in the ground. So you guys think about it. If the tree is leaning to the right, like I kind of drew, my stake is going to be on the left because you're trying to pull the tree back upright. If you drew your tree leaning to the left, your stake is going to be on the right so you can pull it back upright. So you're trying to get the tree back to a 90-degree angle. So it says a rope is tied to a stake in the ground like this because you can't just put a rope on the ground. So it's on like a piece of wood or something like that. You guys have seen that around like baby trees that they plant. And it says to the tree at an angle of 23 degrees. So that means this right here is 23 degrees. Okay. The stake is 6 inches off the ground and the rope reaches 18 feet up the tree. How long is the rope? So, let's see. We said the stake is 6 inches off the ground and this is in feet. So I'm just going to do 0.5 feet here and convert it right away. We want to know how long the rope is, and we know it reaches 18 feet up the tree. So even though the tree's at a diagonal, I'm going to make this my right angle because it's 18 feet up the tree. And the measurement is a vertical measurement. Okay. Now, a couple things here. This is 0.5 feet. This 18, you guys, is 18 feet up the tree. Well, that would be measured like this. So the part of the triangle that you really want is going to be 17.5 because you have to take off that 6 inches, which is half a foot, for the rope. And then it says how long is the rope? Well, obviously this is our rope. So that's what we're looking for. So this is opposite. This is hypotenuse. So again, we're using sine. We have sine of 23 degrees. Oh my gosh. I hope you can read that. I'm sorry. Is 17.5 divided by x. So again, we're going to throw it over 1. We get 17.5 equals sine of 23 times x. So we're going to divide. You have 17.5 divided by sine of 23. And you have approximately 44.79. Whoa, that is not a 4 even close, but it should be 44.79 in your calculator. Now, you guys, a lot of times, like the problem above, we added 5 at the end. We don't have to do that here, okay? Because, okay, let's see. We have approximately 44.79 4.79 feet. There we go. All right, cool. So you guys, this is my final answer because I already took that 6 inches, the 0.5 feet into account when I subtracted it from the 18, so I don't have to do it again. Whereas up here, I had added at the end because I found the short distance and needed the whole. Here I was given the whole distance, didn't need it, I had to cut it off and use the short distance. So that is your final answer. Okay. All right, so homework tonight, practice these. You guys getting that picture is the most important. Focus on the picture. The trig is secondary. You guys know how to do that by now. Come see me with questions.